All right, 7 people in the waiting room. Here we go. I see some people have trickled in. How's it going, everybody? We're going to give everyone a few minutes until they hop on. Feel free to go camera on or off today, whatever you feel comfortable with. Hopefully somebody has a drink in their hand. I poured one up.
Cheers.
Cheers. For those hopping on, we're just giving everyone a few minutes till they show up. I know some people are running from meetings right now. Thanks for hopping on today with us as well.
Yeah, we tried to play some holiday music, but the noise filtration for Zoom is really good. It kept it out.
It was filtering the music out. I was going to play some Christmas music, so apologies about that. I'm sure you'll hear enough over the holidays. We'll get started at the in 2 minutes. All right, let's go ahead and get started, everyone. So I'll stop sharing my screen here. I wanted to thank everyone for hopping on today. I know some people will be trickling in, so we'll be sure to admit them into the room. Really appreciate everyone being able to take some time out of your day to get to learn about something, have a cocktail, and something new, and have a cocktail. I'm currently drinking something new I've never had, a peanut butter tequila. So very unique. We'll see. It tastes pretty good, actually, and hopefully you guys have something pretty interesting for yourselves. So with that being said, my name's Austin Trika. I know some of you I've gotten a chance to meet with before and speak with in the past. I started at Insight Finder AI about 6 months ago. And it's been really a blast to hear what we're doing over here, and excited to show you directly from our CEO exactly what we have coming up for next year, as well as our current product in the IT space. So, with that being said, I want to do some brief introductions. John Whittington, our COO, is on the call today with us, as well as our CEO, Helen Gu, who's going to be walking us through the product. So I want to pass it off to John. He can tell you a little bit about his history and how he came to the company. I know from some of you, Big Panda is originally where I worked at, and some of you have gotten a chance to meet and set up some meetings over here with to show you what we're doing. So looking forward to it. Thank you everyone for hopping on, and John, I'll pass it off to you.
Great. Thank you, Austin. As Austin said, my name is John Whittington. I'm the COO here at Insight Finder based in Raleigh. My drink of choice today is a little Southern bourbon. So hopefully you guys are all enjoying something here at the happy hour. I wanted to just say, for me, the last... We got Neil. Neil's at his happy hour.
Yeah, I muted Neil. Sorry about that. Go ahead.
No, that's great. That's great. So what I was going to say is, for the last 20 plus years, I've been working in the software industry. A lot of that time has been in management monitoring tools. And, through that, one of the last ones that I tried to start, we were trying to figure out, what normal is for an environment. And we thought that if we could track all the metrics and understand what this hourly kind of idea was, like, is that database response time normal for this, 5 o'clock on a Thursday? So we thought we had something special. We were trying to build it. Our name was terrible. We called it No Normal. Everybody thought we were saying NO normal instead of KNOW normal. And so, let alone from the marketing disaster, we actually had of course, the effort to try to build it. And the engineers were overwhelmed. It was extremely difficult. And as that was going sideways, a friend of mine said, you're saying the same things that a friend of mine who's a professor at NC State are saying. And I think you two should meet. And I said, well, I'm all for it. And so I was introduced to Dr. Helen Gu. She's a teaching PhDs and masters and so forth at NC State, all about machine learning. And she had a lot of years of experience. She'd even worked on Watson at IBM. And it took one meeting. And in one meeting, we realized that she was light years ahead of us. So with that said, I think it's important to know that that forged a relationship there, and the company has been off to the races, and we built something really special that we look forward to sharing with you now.
And Helen, we'll pass it off to you to go ahead and introduce yourself and tell us a little bit about your story and how the company formed.
Yeah, absolutely. Thanks, John. And so, hi, everyone. My name is Helen Gu. I'm the founder and CEO for Insight Finder. As John mentioned, I'm also a professor at NC State. So I started Insight Finder actually completely accidentally. So we have been doing research in this area using machine learning for automatic distributed system management for the past 20 years. And so we have been publishing research papers in the space. And so a lot of companies, they read our research papers and reach out to us saying, can we use it in real world? And one of the companies is actually Google. So I spent actually my sabbatical year at Google and help work with their SRE side by side to test our algorithms to see whether we can detect problems in Google Cloud infrastructure. And at the end, we actually showed to Google that not only we can detect much more precisely those problems, but also can scale to the, really the Google scale, right? So in the end, they actually licensed the technology. And after I seen this technology works in real world, I basically started Insight Finder. So it has been a blast working with a lot of experts in different domains. And so today we would love to share some of the stories we learned, some of the insights we actually gather with our customers together, and to share our journey with everyone. All right, so I'll start it. Definitely we want to make this interactive. If you have any questions, feel free to actually raise your voice and ask questions. All right, let me share screen.
Yeah, and if you feel comfortable, you can put them in the chat, and we'll monitor the chat as well.
Yep. All right, do you guys see full screen?
We do.
Okay, cool. All right, so today we're going to talk about how we can use AI to leverage the technology to actually help to improve the IT and the AI monitoring, right? So we all know like the system become a lot more complex, and those system, in order to tackle this complexity, we deploy a lot of tools, and those a lot of tools generate tons of data. And so those tons of data basically impose a big burden to all our heroes, which are basically you guys, right? So our operators has to actually go through those, scan through all those data, massive amount of data, and try to figure out, is there anything wrong in my system? And how, if something actually, there's a system downtime happen, and how do I fix it quickly, right? Just like yesterday, Meta has actually huge outage yesterday, right? So this problem is actually a very hard problems, and so essentially we build this AI engine specifically for this hard problem, right? So we have basically hundreds of out-of-box integrations, allow our operators to actually analyze all kinds of monitoring data from all kinds of tools they have, whether this on-premise tools, traditional legacy system, or cloud systems. So we can all support them. And we are data agnostic, which means you can analyze metric data, log data, trace data, no matter where they come from, right? Whether they are from Prometheus, Splunk, Elastic, so we can support all of that. So our AI engine basically first provide this unsupervised machine learning algorithms that can automatically learn the dynamic normal patterns of your complex systems. And then we can actually detect the deviations from those normal patterns, right? And a different time and a different context. So which makes the anomaly detection, the problem discovery a lot more automatic. And so also much more accurate, right? So that's basically the reason why Google licensed the technology and deploy within their cloud. So we also have another part to leverage the most recent large language model technology, right? So the GenAI technology, we have this specialized IT operation LLM, which basically get fine-tuned with all the special domain specific knowledge for IT operations and AI system management as well. And this LLM is customizable by the customer data, and you can actually further fine-tune this model with the documents from your internal systems like Jira tickets, ServiceNow tickets, etc. So after this AI engine actually sifts through all this massive amount of data, and we can actually produce basically proactive problem detection, right? So help our customers to detect problems much earlier, right? And rather than wait until customers to call them, we also help provide the context, right? Why those problems happens, and provide the root cause analysis and summary. And so we also provide not only the problems and the root causes, but also make suggestions, right? How to fix those problems. So we can generate recommendations and even perform the remediations automatically. So that's basically the product, the platform offered by Insight Finder. So now I'm going to actually explain a little bit, right? So why Insight Finder, right? So you probably heard this page from different vendors, and so there's a lot of like noise on the market. So we want to actually kind of highlight several distinguishable features from Insight Finder. The first one, as I mentioned, right? So because we have this very powerful unsupervised machine learning algorithms, we can actually detect both known and unknown problems. And we don't require user to set thresholds for every metrics, every instance anymore, right? So a lot of customers, when they come to us, they basically saying like, we are basically tracked by those, rules and policies we have to set, right? So when I worked at Google, one of the systems, actually no one actually can touch it because there's hundreds of thousands of rules, thresholds specified. No one knows all those rules. What does it mean, right? And so the people who actually create those rules already left Google. Also, there are a lot of problems with the existing solutions is that they typically cannot make a predictions, right? So they only look at basically the alerts based on the predefined thresholds, which means you are detecting the expected problems, and you only raise alerts when those basically the expected problems happens, right? But a lot of times when those unexpected problem happens, and those typically are not covered by the existing rules. And so because we are performing machine learning online, so we don't require the user to actually manually tune the model all the time, which is one of the reasons why the other anomaly detection solutions like Watchdog in Datadog is very noisy. In addition to basically the unsupervised machine learning part, we also provide this multivariate analysis, right? So we are not doing anomaly detection just based on individual metric. We are looking at the whole system holistically, and we can analyze multiple metrics together, right? And so that's basically the power why we can actually detect those problems are typically missed by the univariate threshold-based approach. We also provide a multimodality analysis, the causal inference part, right? So because like the key thing for root cause analysis is to identify the causal inference, right? So what's the relationships among different anomalies with incidents, right? A lot of other tools, for example, Big Panda, Mooksoft, and they are more kind of event correlation tools and help you to actually correlate what are the concurrent events happen. But in order to find the root cause, what matters is what happens before the outage, right? So that's basically the causal inference algorithm, which is very different from the correlation. And we also support multimodality because you don't know where these root causes or early problems manifested, whether or captured in logs or traces or metrics, right? So because we can analyze all those data, we are not tied to any particular monitoring tools, right? So you don't have data locking issue, and you can switch to any monitoring tools, whether from like Datadog to Prometheus or Prometheus to Datadog. We can support all of that. And we can also help you to actually combine the information from Splunk, like log data, to the metrics from Prometheus data. So you can actually understand, oh, I have basically a response time increase. And the reason is that I have basically a warning messages here, right? So this is basically allow you to combine all the information from different sources. And so we are system agnostic because it's unsupervised machine learning. So it doesn't require the user to do extensive configuration and tuning. So we also doing that using stream-based machine learning algorithms. So it's highly scalable, right? So as I mentioned, it has been tested by Google. So it's extremely scalable, and also we perform all in-memory processing. So it doesn't require basically heavy storage requirements. So we have working with many Fortune 500 companies, and so the products has been actually running in those Fortune 500 companies production environments for several years now. And so next, I'm going to share some of the success stories here. The first success story I want to share is basically we partner with Dell and deploy the systems, the AI-driven IT management systems in one of the top 4 US banks. And so there we basically collect the data across network, storage, VM, hardware, everything using the all kinds of monitoring tools, and eventually we actually consolidated all the metric data into Prometheus, and then feed it into Insight Finder. And also all the logs are actually aggregate in Elastic and then feed into Insight Finder as well. And so because this system is huge, right? So we deploy this over 6 data centers across 4 continents. And so many, many machines, many clusters. And so if you collect all the data in one place and doing processing there, so it's not scalable, right? It also imposes very high network cost, but also because this is a bank customer, so they have air gap environments. So it's very hard to actually get the log data outside the air gap environments. So what we did here is that we have this distributed AI platform. So we provide this edge brain, which performs anomaly detection and edge processing like log to metric transformation on the edge. And so we can extract important information like key anomaly messages from the raw log data and only forward those anomalous data to the membrane, perform the causal inference and as well as prediction. So as a result, we can help them to reduce their log monitoring costs by over 95%. Just look at the normal data, but also, if we just look at the anomaly data, then we can actually reduce the traffic by over 99%. We help them to actually predict many major outages ahead of time. So they used to have 1 or 2 incidents per every 2 weeks, and now they have rarely any major incidents every quarter. So because we always help them capture those problems early on, and so they actually can fix the problems before their customer even notice that. So we also have basically a deployment in one of the top US credit card company. So this is a AI platform. So they're running all their AI models, including fraud detections, security attack detection models on top of these Kubernetes environments they maintain inside. And so because this is a credit card company, all the transactions has to actually go through their platforms in real time, right? So they want to actually go to even second level detection. And so we help them to actually detect any availability issues within 1 minute, right? So they have basically very high availability requirements from their customers. They have pretty much like 5 9 requirements from their customers. And so we also help them to actually not only detecting those problems quickly, but also help them to figure out what causes the problem, right? So they have data spread out across different data sources, and they have server, they have the cache like Redis and network metrics. And so before they cannot actually relate them to the AI systems, and now basically we help them to analyze everything together. So when they have the availability drop, and before they don't detect it until the end of the day, they doing manual analysis because this large amount of log data, transaction log data, are basically stored in Elastic, and so you have to actually perform indexing and then query and then and build the query, and so all those things take hours to finish. So now we basically doing the log analysis right away. So we actually query the any incremental logs, push into index into Elastic right away, and we don't rely on Elastic any indexing or Elastic functionality to perform this anomaly detection. And we help them to perform this log to metric transformation from their all kinds of error logs, right, and 500 logs and the successful logs, and we compute this availability metric for them automatically in real time. So not only we can detect the problems, we can also correlate those problems with all kinds of infrastructure issues, right? So the first one, and they have the availability drop, and we help them to localize to the TCP congestions on one of the nodes. And the second example is that when the availability drop happens, and we localize to the high disk writes on one of the server nodes. So this allow them to actually quickly pin down the problems. And so this is another example. We work with one of the investment banks. And so we help them to monitor their network data, their infrastructure data, their application data. All those data used to actually separate it in many different tools. and they cannot even see anything like together. So they have to rely on bridge calls, right? So say, hey, I think there's a network issue. Can you check it out, right? And when the network guy got a chance to check it out and the problem is already gone, and they say, oh, that's not the problem. So there's a lot of like, kind of bridge calls and the kind of, recurrent issues because the issue happens again and again. So this one, we help them to identify, okay, there's actually a TCP connection issues called string connections. And so this basically cause the connection not close properly. And so when that happens, the server actually is not be able to handle any new connections. And then when the new connections come in, and then basically the system start to actually just close the connections and retry. And so you can see basically becomes kind of like, DOS attack to the servers, and the server basically eventually become really overloaded and shut down itself. So this is one of the issues that we help them to actually learn. And so and then we will be able to predict that right hours ahead, so they can avoid these kind of issues in the future. So we also perform like a very sophisticated causal inference among like a microservices architecture, right? So there's a lot of like components in microservices system applications. And so how do you identify the causal chain, right? So when there's a problem in web portal and it causes basically RabbitMQ get a backlog. And so how do you know when this problem starts and how they propagate into your system? So we can actually perform this like causal inference and this dependency graph inference from the data we received from the monitoring data. So we also provide this very convenient incident management solution, right? So one of the things you want to do is that when you receive an incident or receive problems, anomalies, you want to understand whether this is recurrent problems, right? So we can help you identify automatically whether this issue is recurrent. We also allow you to suppress certain redundant alerts based on the pattern we recognize. And we also identify whether this problem is widespread, right? So when you have a problems, is this like, across different systems at the same time? So this is all allow you to actually see all this information in one place. We also have the LLM support, like I mentioned, right? So instead of just give you basically the numbers, and we also transform those numbers into English descriptions. So the operators like a level 1 or level 2 support engineers, they can actually better understand, okay, what are the insights extracted by us, right? For example, there's an outage happen, then we basically will lay out, we'll group those root causes and lay out the time order, right? So first we see that there's an update to check out service component, and then we start to see the system resource issues. And so this probably start from memory, CPU, then to the load, and then basically we see there's application error happen on the file uploading failure, right? So this is basically allow the operator to easily consume those root causes. They can also give feedbacks saying, okay, whether those root cause summary is useful, and they can edit that and then basically further fine tune the model. And we also provide the recommendations, right? So when you see these root causes, what should you do? And so we basically give the recommendations based on the a lot of knowledge we learned. And so in this case, we'll suggest check the deployment, because the deployment is the first step in this causal chain. And then basically we say, okay, check the bottleneck resources. And so similar thing, you can actually give feedbacks. We can also use our LLM to generate. So it's a fully functioning chatbot. You can actually interact with the chatbot to ask the robot to generate basically the scripts to reverse the deployment, for example. So we also provide the fleet-wide monitoring, not just to focus on individual applications or systems. And so we basically tell you, okay, we can help you to group all your machines into different regions and categories, applications, business units. And this is actually a time bar. You can slide that and see like whether these problems happens widespread or just like, sporadic on a few nodes. Similar thing, we can generate the summary. And so basically give you the fleet-wide basic summary on where the problems exist. So we also actually recently released a new product built on top of our UIE engine. We have this new AI observability product, which is more tailored toward monitoring the models. So those are the common model problems we saw with our customers, right? Model drift is a very common problem in any machine learning models, right? So when the model behavior changes from the normal behaviors. Error hallucination is a big issue, right? So when you ask some questions to LLM, like ChatGPT, right? So you ask 13.11 and 13.8, which is bigger, and ChatGPT will tell you 13.11 is bigger, right? So this issue exists in a large language model because there's inherent training problems, right? So it's important to catch them. Similar thing for large language model, if you deploy that for your mission critical applications, then the availability and the response, the performance is important. And also for large language model, if you actually have, malicious prompt inject to your system, it will sometimes reveal the information, the confidential information, and sometimes it will tell the wrong information. So all those things, we actually developed a new product to try to help with them. So first we have this rule-less data quality surveillance. So allow you to detect any data quality issues like abnormal numerical values, abnormal categorical values, missing data values, the data integrity issue, data gap issue. So we can actually use our engine to detect them. So we also can detect the model drift, right? So whether this model is actually deviates from its normal behavior. So this is an example of the fraud detection model. And so at some point you will see, oh, this fraud detection model actually produce a lot of high risk scores. And so which means it's actually denying a lot of transactions, right? For a credit card company, that means it's you are actually probably have a lot of false alarms, and so you are denying a lot of transactions from customers, which will make customers very unhappy, right? So especially during the holiday season, you are trying to buy some gift, and so somehow the credit card actually deny the transactions, right? So those kind of issue will help our customer to capture that in real time. Will also help customer to identify why this model drift happens, right? So in this case, we find, okay, some transaction amount is missing value in certain data records. So all in all, we basically developed this AI-powered IT and AI observability platform, help our customers to reduce the MTTD and MTTR. So we help them to figure out what's the problems, what's the root cause behind those incidents quickly, and we help them to actually stop the problems before customers actually got impacted. So this is basically concludes my presentations, and so very happy to actually take any questions from here. And so of course there's a lot of details omitted here, and so happy to schedule follow-up meetings on, and so we can go we can have a deep dive sessions later. Yeah.
Thank you very much, Helen. That was very insightful. We really appreciate it. I want to leave it open to the floor if anyone has any questions. I know some of you have gotten to speak with before, and some I will be coming up soon before the holidays. So yeah, if anyone has any questions, feel free to put them in the chat, or you're open to going off mute if you feel comfortable with that.
So I cannot see the chat unless I stop sharing. I'm going to stop sharing in case there's some questions in chat.
We
And
do.
I believe um,
Byron asked the question. So he said, what kind of compute resources are needed if we self-host the AI in terms of the vCPU and memory?
yeah, so the so we are actually doing stream machine learning. So in that sense, we basically are very resource efficient. Generally speaking, we work with our customers like to see like what's the size of their environments, and so what's the generally speaking like for 8 core machine and 32 GB memory, we can actually process millions of metrics in real time without any problem. Log data. So essentially, we work with those Fortune 500 companies, and we can push to like 100 200 million log entries per hour without problems. Using just regular 32 GB machine and then 8 core machines. Generally speaking, our algorithms is a lot more efficient. Yeah. So that's the reason why Google licensed it. And so when I test the algorithms, and they used to use some clustering algorithms, and so like Amazon has some class anomaly detection algorithms using isolation forest tree, and those are basically very canonical like clustering algorithms. And so when the same amount of data, I remember we run those algorithms, it take like weeks to finish, and using our algorithms, it's more like minutes. The fundamental reason is that the complexity of our algorithms is ON. Most of the clustering algorithms, anomaly detection algorithms, has complexity of ON cube. So N is basically number of metrics you need to process. So as you can imagine, so that's a huge difference. And also most of the algorithms, they are doing all univariate analysis, which means they process metrics one by one. So we are doing multivariate, we can process millions of metrics at the same time. So we can support like high dimensional space very easily. So that's another reason why we can do this like much more efficient. Yeah.
That was a great question. Thank you, Byron. Keshav has a question for us.
So
Yes.
the question is, do we have any recorded deep dive presentation? Yeah, so I have several like research talks, and so we put it on our website. We also have like, white paper to talk about the technical details. So happy to share.
Yeah, I'm happy to send some info your way as well, Keshav. Does anyone else have any other questions? Thank you, Zeke. All right. Well, if no one else has any other questions, we can jump into some fun questions that I might have for the group here, and we'll keep it very kind of lighthearted, maybe get some feedback here. So let me share my screen. Okay. Wanted to start this off with a fun one. If anyone here has a best meeting a celebrity story, maybe it was something out in person. I know John has a good one we were talking about yesterday. Maybe would you like to start us off, John?
I can definitely do that. I My wife and I used to live in Manhattan, and one day she walked right out of the gym, and when she did, a guy was walking really fast at the same time. Literally, just neither one of them were paying attention, and they smashed into each other. I mean, faces and feet, everything. I mean, full. And she stepped back and looked, and it was Charlie Sheen. And she had a really good laugh about that one. So anyway, that was a good one. And then there was another one where I was at a restaurant one time, and I was kind of looking past my wife because there was this woman back behind her, and I was just trying to figure out who it was. I've never seen anybody quite like her before, and my wife kind of realized that I wasn't paying attention. And during the dinner, she turned around and she looked behind me or behind her, and then turned back to me, and she said, "Oh, yeah, I'll give you a pass on this one for not paying attention to me. That's a Victoria's Secret supermodel." So yeah, so we've had a couple little brushes like that that are always kind of funny to me.
I have a fun one. My dad said that we were going to go on a boat. So I live in Southern California, in Newport Beach specifically, and we were going to go on a boat for the 4th of July. This was 2 years ago, and he said it's going to be my friend's boat. There might be some very wealthy people there. Just go introduce yourself and say hi. And so I did, and I met some people, and sure enough, Dennis Rodman was on the boat with us, and so. You can imagine he's a character. He lives actually down here, funny enough. So, and for those of you that don't know who that is, he's a multi-championship NBA superstar that played with Michael Jordan for many seasons and many years. So, very long time in the NBA. He's retired now, and I thought that was pretty cool. He's a very nice guy in person.
That's great.
Yeah, does anyone have a story they'd like to share?
Austin, I have a story.
Let's hear it.
That's great.
I live in the Tampa Bay area in Florida, and way back in the day, my wife and I went to see a comedian by the name of Yakov Smirnoff.
Okay.
Funny guy. But the opening comedian for this guy was this nobody. Nobody's heard of him, but a funny guy. Uh,
Yeah.
turns out his name was Jerry Seinfeld.
Oh my gosh.
That's
That's
great.
hilarious.
Wow.
Man, that guy's a character for sure.
He did a little better than Yakov Smirnoff. So
Yeah, it's kind of funny how their fortunes turned out, right?
Huh. Yep. That's funny.
oh, that's great.
Does anyone else have another story they'd like to share? Could be anyone. Maybe you ran into him, maybe you saw him out at dinner.
I just a quick one. So I live in Soho for like a few years. And so one day I was walking on the street and suddenly I realized everybody's like stop talking and become really silent. And I don't know what's going on. I keep walking and then basically suddenly I see like they're women and with a little kid in front of me. And so I think a lot of like people like far away, they're paparazzi, they have like huge cameras to point to this lady. And I was asking someone, actually, there's a person actually beside me. I was like, who is she? They tell me this Jessica Alba. So it's a interesting.
That's awesome.
That's fantastic.
She might live in New York. Maybe she was there for a movie or something. That's pretty funny. Well, before we move on, does anyone else have a story they'd like to share? All right. We'll move to more of a fun, we'll say technical one. Um, so how do you see AI helping you with your job maybe in the next 10 years? Do you see it as an advantage, disadvantage? I know a lot of businesses have been incorporating that now, and I feel like it's only helped, make things more efficient and effective for their business. So just want to open it up to the floor and see if anyone has any, ways that they're using it today, besides a lot of the vendors, obviously.
This is Keshav. One of the, obviously, you guys are talking about it, right? My expectation is that I think this will be a given in 10 years from now. It will be AI engines figuring out the routine and figuring out the root causes that are causing any issues in the IT space, and probably they'll cut down the MTTD, MTTR, and probably there will be more of a proactive approach rather than a reactive approach as we have today. And probably you'll know about the problem before you see it's happening, unless it's something like a thing that even the AI engine cannot predict because it has never seen that, it never thought about it. That will always be there. So I think, obviously, I think we will get to a place where uh, routine problems will get resolved sooner rather than later, and before even the business users sees the impact of those issues. I think we're going to get, I think uptimes will be a lot more drastically improved, and engineers will be working on more important stuff than going through a lot of data to figure out patterns. So that's the expectation. And anomaly detection will become a routine thing, as I'm assuming that you're familiar with some of the patterns. Obviously, if you cannot detect patterns that are, you don't know that that is a pattern, right? And you can't, one of the things you were mentioning earlier about, you don't want to be so uh, locked into your patterns that you'll start impacting end user experience, like rejecting valid transactions. So I think it's a challenge, but I think we'll be doing more higher quality uh, pattern detection, for lack of a better term. So I think we'll get better, but we'll never be satisfied, right? We'll be talking about the same issues at a different scale.
Yeah. No, absolutely. That's a great response. I appreciate the feedback there too. Couldn't agree more. I do think AI at this rate is the future, and businesses that are starting to implement it are making smart decisions. And so we see that, and we know our product's going to be very successful in this marketplace. Does anyone else have any responses, answers they think, or thoughts on this? All right, we'll move on to our last question here. And for some of you that maybe are involved in this, never have I ever had a bridge call for more than 4 hours. This could be, um, you know, a fun story, or maybe not so fun story. Maybe you had a call that took longer than you thought. I've heard of multiple day bridge calls before in my time. Just curious, what are some stories you guys might have that you're open to sharing?
I don't have any exciting stories. I've been on bridge calls more than 4 hours, but just makes me think it'd be nice if AI starts taking them all.
I love that. Yep, just automatic person.
Yeah. I mean, I'm sure they'd do better, I mean, they won't even need the bridge call, is what it'll come to. But they will communicate with each other, I'm sure.
They paid you when they actually need you, right?
Yeah.
Yeah. Yeah. Oh, that's good. Does anyone else on the floor
And I
have any?
don't know what the question means, but if the answer is I never had one, no, that's not true. I mean, I mean, there are fewer nowadays, but 10 years ago, we used to have a multi-day bridge calls, living off pizzas. So that
Huh.
reduced quite a bit because we are getting better at because we have been improving our monitoring breadth-wise, laterally and vertically. So we are getting deeper into our systems, embedding more into our processes as well as software. So we had a better understanding, and now we got better. Previous 10 years ago, if the question was this what happened, or are we monitoring this? The answer was no. We don't know what happened. Are we monitoring that? No, we are not monitoring it. Today, the answer is, we already have standard processes taking over and things getting escalated and people getting called. So probably I don't even know that something occurred and somebody got notified and something got resolved. So the only holy grail part that we have not accomplished yet is that anomaly detection. I think Austin, I probably talked to you like last year, I think, about
Yep.
this. So anomaly detection is the challenge, right? Now the thing is, how do you figure out anomaly detection without going overboard? Like that was mentioned earlier. So thanks.
Absolutely.
I'll chime in here, Austin. This guy always made me laugh. But this is about 20 years ago. I used to work very closely with Verizon, and they had some big bridge calls. And there was a guy that was in the middle of all of it. His name was Bruce, and he's long since been retired. But when you would go visit Bruce, he would meet you in his office, but he had two phones, and he would turn around in his chair and talk to you, and he'd have one phone on one ear and one phone on the other ear, but he's meeting with you. So he had two bridge calls going at the same time,
Oh my
and
gosh.
you had to get through the two bridge calls while you were talking with him. It was the most ridiculous thing. He was funny about it and he handled it well, but it just showed how chaotic his life was. As his career was there at Verizon for years, he did that.
Sounds very stressful. Oh my gosh. Especially if that's every week. Oh man.
Oh, he did it every day. Yeah, it was all the time.
I'd
Yeah.
imagine they've made that a lot smoother process there at Verizon now. Huh.
I was just going to say, I wonder how much, cloud service has reduced those calls as well. Because, you're right. I mean, they're not happening like they used to.
Yeah.
Yeah.
And we've seen it decline and decline over the years. Each year it's getting better and better, and less calls, less downtime, less people having to firefight, and solutions like ours that can help, and a lot of the vendors out there that can help as well.
I mean, we had a team that's just created for the SWAT. It's called the SWAT group. And
Yep.
their primary purpose was just to organize data, pull data from multiple sources. And this is like a multidisciplinary teams, network expert, systems expert, application, space expert, and they actually are now that those teams don't exist. And pretty much it's like, it's really real and it's becoming rarer. Like Bill Perry just mentioned, there are fewer and far between and a lot shorter. But still, when it happens, it looks very bad because now the people are more sensitive for any outages or performance degradations. So,
Yeah. Good point.
That is a good point. Well, I know some people have trickled off. But yeah, we wanted to leave it at the end. If anyone has any last minute comments or questions, I know there's a few folks on the call I'm going to be speaking with and have spoken with already. So yeah, I wanted to leave it open. If there's nothing, we definitely will send you some information and the recording we can. If you're open to that, we can send you the recording of this presentation as well that you can share internally with your team. But yeah, we'll leave it open if anyone has anything last minute comments.
I just want to say, sorry I joined late, so I would like to get that recording.
Absolutely. No problem. Happy to send that over.
Thank you all for joining. It's really great to have a conversation like this and enjoy it over a happy hour.
Yeah. Thanks, everyone. Have a good holiday week and hopefully no downtime.
Yes. Thank you.
Thank you.
Thank you guys,
Bye.
everybody. Have happy holidays. Take
See ya.
care.
You too.
Thank
All
you,
right.
everyone. Take care.